Let's go to page 619, and this is lesson 13-3. The purpose of the objective is to use periodicity and symmetry in graphing functions. Now, the word that periodicity means that the function is periodic. That means it repeats itself after a certain amount of time. A common example would be like a clock. The clock repeats itself every 12 hours. Okay? And the smallest amount of time that it will repeat itself is called a period. Okay? So the period of a clock example would be like 12 hours. Now, the period of the second hand would be 60 seconds because it would repeat every 60 seconds. The minute hand, the periodicity would be 1 hour. It would repeat itself every 60 minutes. So you can period is amount of time it would take to repeat itself. Okay? Now let's go to example 1. So example 1, you have this graph, and it tells you that the period is 2. Okay? So that means it repeats itself every 2 divisions. So from here to here. So that's period. So if you graph from -5 to 5, this would be the graph, right? So the period is 2. That means it repeats itself every 2. Okay? And so this is an example of periodicity. Okay? That repeats every 2, right? So from here to here, from here to here, from here to here. So this is one period, this is one period, this is one period. Or this can be one period, this can be one period. So you can pick any point to start, and when we get back to the exact same point, there will be one period. Okay. Okay. Now, the function, some of the functions are R function. Now, R function is when you replace x by -x, the y would become opposite. So I will go over more example later on that it will be easier to understand. Even function is when x is negative, the function does not change. Okay? So like this one, or easy way to see that even function is a reflection. So if this is a reflection of this, when they are reflection of each other, it would be even function. This is example even function. And the way you can tell is that, let's say, for example, when x equal to 1, the y is equal to -1. And when you make the x opposite the negative, so notice x equal to 1 and x equal to -1 have the same value. Okay? So that would be an even function. Or, again, another way to tell is when x equal to 2 and x equal to -2, right? So +2, -2 have the same value. See that? Or, again, so every value of x and -x will have the same value. So that's what this is saying. In that case, it would be an even function. Okay? Now, if they are opposite, then it would be odd function. Now, sometimes a function can be odd, even, or neither. Okay? So you have to check to see if it's odd or even, and if it's neither one, then it's neither. Okay? So those are classification of odd or even functions. Okay, so let's go to example 2. So that's how you can tell by using the graph. But if the graph is not giving, then this is how can you tell if it's odd, even, or neither by the calculation. So on page 620, example 2a, you have f of x equal to x squared over x4 plus 1. So what you want to do is you want to figure out what is the f of -x. So when x becomes -x, so again, x becomes -x, and you simplify. So this one, the negative square will give you positive. So you're going to get x squared over x to the 4 plus 1. Then you compare with the original. Notice f of x equal to this, f of -x equal to that, and they're exactly the same. So f of x equal to f of -x. If they're the same, so again, if the x and -x have the same value, then it's even function. Okay. Okay, let's go to 2b. You have g of x equal to x cubed minus 4x. So again, let's go and figure out g of -x. So you substitute. Again, remember, whatever you substitute, put inside the parentheses. Okay? And then, so g of negative x equal to negative x cubed plus 4x. So notice that this is equal to negative of that. Okay, so g of negative x equal to negative g of x, right? This is exactly opposite of that. You can compare. So this is the R function. Okay. So again, so this is even, this is odd, and it can, remember a function can be odd, even, or can be neither. Okay. Another quick check is that if the exponents are even, right away you can eliminate the R function. Okay, because when exponent is even, then you cannot have cannot be R function. Same thing, if the exponents are odd, it cannot be an even function. Okay, but the thing is that you don't know if it's neither or not. So this one you don't know if it's going to be even or neither, so you have to check it out. This one again, it can be odd or neither, so you have to check it out. Okay. Okay, let's go to 2c. So you got h of x equal to x squared plus x. So this right away, I can tell this is neither already because of this, because it's even power, so this cannot be odd. Okay, this cannot be R function. And this is the R power, so it cannot be even function. So if it cannot be odd and it cannot be even, you have to be neither. Okay? But again, if you don't see that right away, you check it out. Okay? So you substitute. So h of negative x is equal to x squared minus x. Okay? So this is not exactly the same, right? In order to be even, they have to be exactly the same. So these are not the same. Okay? And these are not exactly opposite because to be opposite, they have to be negative and negative. So again, this is neither. Okay? And again, if you know what you're doing, you don't even have to go through this. Again, because what I say, right? Because this is even power, that means it cannot be R function. Okay? And because this is the R power, so it cannot be an even function. So this one cannot, this one till it cannot be odd, this one till it cannot be even. So if it cannot be odd or even, it have to be neither. Okay. Okay. Now let's get back to example 3. So this part of the graph is given, and so you want to get an even function. Well, remember, even function is when the graph is reflected over. So when you reflect this over, so this would be the example of how to make this an even function. Okay, again, remember, when x equal to 1 and negative 1, so 1 and negative 1 have the same value, 2 and negative 2 have the same value, 3 and negative 3 have the same value. See that? So that's an even function. To make an R function, you have to rotate. Okay, you have to rotate 180 degrees so that they will have opposite value. So 1 and negative 1 have opposite value. See that this is 1, negative 1. Okay? 2 and negative 2, again, they have opposite value. Right? You have 1 and negative 1. And 3 and negative 3 have the, again, have opposite value. You got 0 and negative 0, which is also 0. Right? Again, it's rotation. Right? So again, this is an example of even function. This is an example of R function. Okay? Okay, so let's just go over the oral exercise very quick to see what kind of function is this. So this is rotation. Okay? So this is a rotation. So this is the R function. Again, because 1 and negative 1 have opposite number, right? Right? 1 and negative 1 have opposite number. So this is the R function. This one is neither because look over here. So 1 and negative 1, right? They are not opposite and they are not the same. So this is neither. This one, 1 and negative 1 have the same value. 2 and negative 2 have the same value. So this is the even. Okay? So again, odd, neither, even. Okay? So again, R function, by looking at the graph, is rotated. Okay? Even function from the graph is reflection from your geometry, and neither is neither one.